Hi, today we're going to be talking about waves on a string, this part 2, which covers standing waves. So a standing wave is a wave that reflects across a boundary. So remember we talked about the boundaries in the last video where they get reflected. So if we had a wave that went like that, a little pulse that went like that, it would be reflected to look like this. So they reflect across a boundary and they interferes with itself. Remember, we can have constructive or destructive interference. Constructive is when we add. Destructive is when we subtract, basically, and we get a larger hump for constructive and no hump for destructive. Alright, it's called standing wave because it doesn't move. The crests and troughs don't move. They kind of just go up, they're pulled up, and then they're pulled down, and pulled up and down. Crests and troughs don't move. Alright, so a standing wave looks something like that. And essentially, if you had a string between two fixed boundaries and you pluck it, you're going to get this waveform. And it's going to kind of oscillate up and then down. So over time, you'll see this peak crest, go down and come down here, and then it'll be pulled back up, and it'll kind of just flip back and forth between those two. So if you notice, in this waveform, we have areas where there's a ton of vibration and areas with no vibration. So we call these areas nodes. And if you see, we have 1, 2, 3, 4, 5 nodes. A node is an area with no vibration. There's no vibration in that point. It does not move. It just kind of stays in the exact same spot while these oscillate around it. We also have these humps. These are called antinodes. If you notice, we have 4 of those. So, antinode. These are areas with vibration. And if you draw yourself a little axis right here, you can see that at x equals 0, you're going to have your nodes. And then when you have a positive or negative y, those are your antinodes. All right, so you have some displacement. One thing to keep in mind is that we can actually figure out how many nodes or antinodes we're going to have from the other. So nodes, the number of nodes is always equal to the number of antinodes plus 1. And you can draw this out with different numbers of humps just to prove that to yourself. All right, we have 1, 2, 3, 4, 5, 6 antinodes. And we have 1, 2, 3, 4, 5, 6, 7 nodes.